Good afternoon again. This is Dr. Schulman. I'm doing the Chapter 9 review for all the inferential statistics. So I'm assuming it's just going to be a bunch of t-tests. And here we go. So I'm sharing my screen. I'm going to go right here to modules. We're almost at the very end, which is nice. So I just did most of these. I think I got like the last one up and I left you one to try yourself, but just about all these are ready. I'm gonna do the chapter 9 review and then I'll go through the quiz. So these are harder. Okay, these chapter 9 the reviews are harder. So let's open Pearson. Let's do a couple of these. Make sure we understand how to do them. So let's go to question 1. All right. I'm gonna move my floating head. Doesn't have a lot of here, so I'll help you with the ones that are in a large clinical trial. This many children were randomly assigned two groups. The treatment group consisted of this many given a vaccine, and 30 of those developed the disease. The other students were given a placebo, and 102 of those developed the disease, considering the vaccine treatment group to be the first sample. Assume 0.10 significance, which is better? I would go with the hypothesis test. I think that's better for this situation. Cool. Because when we're just thinking the test, so we want to know if one's the better, like confidence interval is like can we be sure in a range? And I don't think that works for the vaccine. So in general, deal with two population proportions. Which of the following are equivalent? Confidence interval method, p-value method, or critical value method? I believe that the p-value and the critical value are consistent. Okay. And that they will always lead to the same conclusion. Both of these methods use a standard deviation based on estimated values of the population. The assumption that the two population proportions are equal. Ooh, I don't know. It's one or the other. Whereas the other method uses standard deviation based on, I think this is how it works. Nice. At a point of one significance, what confidence level should be used? I believe I'm going with 90%. That is incorrect. Oh, it's divided by 2. Oh, because we don't know which one is bigger than the other. So I believe this is going to be 95%. All right. It is a one-tailed test, 0.90. Oh, it's because I have the decimal there. Oh my God, I'm so stupid. Sorry about that. Because it already had the percentage. Oh, it's 80%. Okay. The claimant part C is tested. We get this level. All right, so for these, I'd put this into StatCrunch and see what we should get. All right, so number of successes in number 1 is 30. And we have a number of observations, which is 199,665. And then the sample two, the number of, we've got 102. And we got 196,249. And we're doing that. Consider we want to say that it's bigger. That this P1 is bigger than P2, so this is going to be greater than 0. We want our critical value to be 0.10. 0.10. All right, let's compute this thing. So oh, but now we want to do this with an 80% confidence interval. All right. Whatever they say. All right, so it says negative 0.000444, negative 0.00444. The upper limit is 0.000294, negative 0.00294. Our critical Z is 1.28. Because the composite does not contain critical value, there appears to be a significant difference. No, there does not to be a significant difference. The cut is the values. Because the confidence interval consists of values greater than or less than the critical value, it appears that the proportion is not significantly different. Appears the proportion is greater than there is sufficient. Sweet. Oh man, I thought I had them all. Let's see how many of them I had right. Well, definitely try your best on these. They're kind of tough. At least I got the right thing when I plugged it in. That's what I cared about. Okay, get over yourself. Let's see which ones were right. Does not contain. Oh, it is 0. Oh yeah, because it should be 0 for the confidence interval. Okay, that's fine. Let's try another one of these. A study was conducted to determine the proportion of people who dream in black and white instead of color. 299 over the age of 55, 60 dream in black and white, 312 under the age of 25 dream in black and white. Okay, complete A through C. Consider the first sample. 55, the second sample. What are the nulls? So the first one is just that they're going to be equal. So that gives us the choices of B and C. Okay, so the portion of 55 is greater than, so that's got to be this one. So null B. Oh, what? These should be equal. Oh yeah, it is greater than. I didn't know this. I had this choice. Sorry, it said greater than. Whatever. I'm over it. I get the Z statistic. Okay, so we got to do the proportions and get the Z test statistic. All right, so if we're doing one direction and it's 0.01, the Z stat should be pretty easy. Oops. The Z stat should be pretty easy for this one. So all you have to do is go to stat calculators normal, and we're going in one direction, and it's saying where is it? Oh, it's the 0.01 significance level. So I just have to make this what? 0.01. But I wanted the other direction. No, I wanted this direction. Why do I want it this direction? Because I just want this little bit. So I'm going with negative 2.33. Let's see if that's the right answer. Or we could do that crazy formula. Oh, because it's greater than. Oh man, it's a positive 2.33. The stressfulness is real. What? What's the answer? 5.90. Well, they had 5.90. Yeah, no duh. So strange. Oh, because I was finding the critical value. Ugh. So I found the critical values had a test statistic. Isn't that stressful? So to get the value they want, go to T-stat. Sorry, we want to go to proportion stats with two samples with summary. How annoying. Sorry, I'm not frustrated. Just sometimes when I get them wrong, I don't like it. All right, so here we go. Okay, so let's go to options here, edit, edit, edit. Okay, so all right, we have 299 people, and how many of them were able to dream in black and white? 60 of them. Now I have 312 people, the young folk. How many of them were able to dream in black and white? 14. We're using a 0.01 significant level, and we want this to be positive. Boom. I have them backwards. 60, 299, 14, 312. There's your 5.9. Ta-da! And there's my 2.32. So that's what I got wrong. The p-value is round to 3 decimal places, 0.000. Ta-da! We got it. So the p-value is less than 0.01, so reject the null hypothesis. There is sufficient evidence to blah, blah, blah. Magic. All right, so I hope that was helpful. Obviously, sorry I mixed that one. Oh, there's one more. So we want to have a 98 confidence interval. So all I'm going to do is just edit this to have the confidence interval to be 0.98. And so now the lower one is 3 decimal places, 0.095. And this one is going to be 0.216. Check. Good job. Oh God, there's more. Because the interval limits in does not include 0, it appears that the two proportions are not equal because the confidence limits include positive, only positive values. It appears that the proportion of people over 55 who dream in black and white is greater than the proportion of those under 25. I know, a lot of thinking, craziness. So just try your best. Oh my God, there's more. I was like, an explanation for the results that those over grew up exposed to the media that was displayed can be used to verify that explanation. I don't like that. I like no. Sweet. So I got that one right. Just try your best on them. If you get confused about it, just do them. Use this proportions. If it has the p's in it, you're gonna be using the proportions. If it has like mu's in it, like means and stuff, like this is another one that's proportioned. Like you can give you any means one. Here we go. So here's one with the means. I might as well do this one. The null hypothesis is that they're always equal. And they say that two samples are independent, simple random samples. Nice, so we know exactly how to do it. I wish the book said that. So is it greater or less than? Magnets are effective in treating back pain. Magnet treatment, so the first one's got to be bigger. All right, the t statistic is, so all I have to do for this one is go to stat, t stat. They say it's independent. We have data, sorry, we have summary. We just drop it in. So mean 0.53, standard deviation 1.05, sample is 26. Mean 0.44, standard deviation 1.48, and the sample size is 26. We want to do this at what kind of level? We're saying that the first one is greater, so that's going to be a positive value. Show the critical value. Now let's just go with it. T statistic is 2 decimal places, 0.25. Ta-da! The p-value is 0.401. I guess this magnet treatment sucks. The conclusion is we failed to reject the null. There is not significant evidence. Okay, confidence interval. I'm just going to use the 0.95. So I'm going to say it's between negative point, oh God, sorry, negative 0.2 decimal places, 0.63. And this one's going to be, upper is 0.81. I'm not using the right one. Okay, so I got to do the variance over one plus the variance over the other. So the difference in the sample means minus E, difference in the sample means plus E. To get E, I need my T statistic that I already have. All right, so I might as well just write up this crazy formula. So it's going to be variance. So it's T times variance 1 over N1 plus variance 2 over N2. All right, and we need to do the square root of this whole thing. Cool. And finally it's mean 1 minus mean 2 minus E. The other side is going to be mean 1 mean 1 minus mean 2 plus E. Okay, here we go. Well, we already got the T statistic, which is 0.25. It's basically just going to be 0.25. I'll do the first part first. So it's I could just do it all together. So equals 0.25 times parenthesis, sorry, times square root parenthesis of so it says the square root variance 1. So another parenthesis. So I need 1.05 times 1.05 divided by 6. Then we're going to be adding that. Adding that to parentheses. Parentheses. Okay, I see I'm missing stuff. 1.48 times 1.48, close parentheses, divided by 26, close parentheses. And then I just need a 1 around the whole thing. I think I got it wrong. Yeah, correct it for me. All right, cool. So this business is my error. And all I have to take is the two means and subtract them from the error. So ready? So mean 1, which was 0.53 minus 0.44 minus this business. Cool. Negative 0.0, 2 decimal places, negative 0.05. And now all I have to do is take this and do a plus here. And now it's a positive 0.23. What? Did all the steps. Let's see what it's supposed to be. So I got the negative 0.05. Oh, it's 0.51. Craziness. Does it appear that? No. I like this one the best. It's not effective because 0 is at the confidence level. I think that's what the answer they want, which is fine. Let me just go back to this one. I know I got these right, but let's try to figure out how they got this confidence interval just for fun. So, options, edit. Let's see if this set 0.90. Oops. .51 and point. It was at 90%. Now, why is it at 90% when this one is saying you're at the 0.05 level? I believe it has something to do with this piece. Our critical value was at 1.6. Was our critical value at 1.645? But that's for z-scores. No, we don't have z-scores. We have t-scores. It doesn't tell us. It doesn't tell us which confidence interval to use. All right, let's see exactly how they got the confidence interval. Considering that was the only part we messed up, and then I'll let you guys try the rest. Let's view the example. Dun, dun, dun. Okay. Standard deviations, independent, random samples, more than 30 of each. Perfect. One is bigger. We got that right. We got that right. We got that right. We didn't do that. We cheated. We just typed it in. 0.015. All right. The p-value is what we get. Now, how do they decide the confidence interval? Construct a confidence interval appropriate for the hypothesis test. Its combination can be found using technology or this inequality. Okay, let's see. Can use the formula. Here's the part. Note that the composer was being instructed to test a one-tailed claim. So the interval should be constructed with a 1 minus 2a. Since we did 5%, 5% times 2 is 10%. That's why it's 0.90. But I'm still going to try this formula one more time. So we have our t-stat. Did I never multiply it times t? No, I did. 0.25 times the square root of the variance squared over 26 plus the variance of the second one squared over the other mean. Do I need an extra one here for this square root? I think I just probably typed it in wrong. So it's the square root of this one times this one over this one. Close that up. Close that up. And then boom. Perfect. And now it's I think I just messed it up when I typed it in because I listened to it like a fool. Plus, okay. I hear you. I hear you. So I need this one fully on the outside. All right, I'm just going to type it into Desmos. I know all the values I need. I think Excel is messing me up. So I just don't like when I get the wrong answer. So it was 0.25 times I need the square root of 1.05 squared divided by 26. And this whole thing's got to be added to 1.48 squared divided by 26. 0.13. Yeah, okay. That's not what I got. So it's 0.13, and then we just have to, all right, get over yourself. We have to subtract the two means. We should get the right answer. So our means were 0.53 minus 0.44 minus 0.132. No, I still didn't get the right answer. I got a negative 0.042. That one's 0.53 minus. Yeah, it's not the right answer. All right, so let's see if what we could do. I was just wondering to see how I could get this at the 90%. Because at the 90%, we got the answers they wanted. And because it was 95 and we're splitting, it's got to be 8 divided by 2. That's why that happens. The critical T is that. Okay, well, I don't know. I guess we just have to use technology. Let's just try one more. We have this data. Just opening it in StatCrunch. All right, so here's our data. Nothing crazy about the data, right? Here's a 0.01 significance. The mean weight of the 1980 population is less than the mean weight of the 2012 population. So we want to know that the mean weight, that the first one is less than the second one. So this has got to be cool. Test statistic is what? So for the test statistic, I'm just going to go to stats, T-stats, to sample with data. Boom, boom, bigger. Sorry, less than. And we want this at what percentage? And not give it to us. When they don't give it to us, I would just use 0.05. All right. We got a T statistic of one. Oh, I didn't pull the variance. Let's pull that variance. I got 1.86. Let's see what this. Do they really pair these? Because that would be strange. Oh, because I have it backwards. I had it backwards. I think it's because I just had it backwards before. Yeah, so I had it right the first time. I just need this to be the right direction. They want the 1988 first for some reason. It's less than that. One is less than two. It's got to be less than zero. All right, so my critical T is negative 1.7. So the population one is the 1988, population two is the 2012. Okay. Do I not pull the variance? That'd be so weird. Oh, I guess they didn't want me to pull the freaking variance. Because that's the answer, negative 1.92. And the p-value is 3 decimal places, 0.067. 0.067. The T statistic is correct. Oh, it's round to three? Yeah, it's 1, 2, 3. What the hell is it? Sorry. I don't know why this is what I'm getting wrong. So I might as well do one that looks like it. So if you're ever confused, you're not sure what to do, you just view an example. Let's open this in StatCrunch. And I'm actually going to read the whole thing. This will be the last one I do. All right, so here we go. We have our data. That looks nice. So listed in company table are the weights. Assume the two samples are independent samples selected from normally distributed populations. So right away, independent samples with data. There's your 1988. There's your 2012. Claim that one is from 1988 and that's population 2. So 1988 is 1, that's 2002. And we want to say that 1 is what? Less than 2. So this would make this what? Less than 0. We're going to use the significant levels of 0.05 and click compute. We got a T critical of negative 1.03, negative 1.03. Beautiful. Okay. We got a p-value of 0.0156, 0.0156. Beautiful. Cool. The alpha level is greater than 0.01, so we fail to reject it. Now we have to find the error. So while either technology or the formula below can find the confidence interval for this, we could just do options, edit, and just change this to confidence interval. And then I believe we just have to drop this to 0.90%, and that should give us the values we want. So they say the confidence interval level is 98% to give a negative 16.1 to 6.7. All right, so I guess we have to do the formula every time. So let's actually get this formula. So if we can get this formula, we should be good to go. So the first formula, all we have to do is subtract the values minus E, subtract the means minus E, subtract the means minus E, and this is where we get E from. So to get these values, I think this is the part I keep missing. So I have to subtract both means. So the first thing I need to do is get means for both of these. So we go to edit, data, calculator, summary stats of columns. And we're just gonna take both of these and click compute. All right, so right away I have what? I have my mean, and I'm gonna write out this formula. I'm just gonna put this at the end of the review. All right, let's get this right. So I believe this was the same sort of mistake I was making just on this confidence interval piece. And I want to make sure everything is correct for everybody. So this is the end of the review. All right, we have the formula. This is for the confidence interval when we're working with t-tests. So it's going to be x1 bar minus x2 bar minus e. And this is going to be the differences in the means And E itself is the T with alpha divided by 2, S squared 1 plus S squared 2 over, oops, over M over M1 over M2. So the first thing we have to do is we just have to take the means and separate them. That's all we have to do first, which isn't a big deal, right? That's not a big deal. So we got the two means of our data. They're right here. So mean one is 82.95 minus the mean two, which is 87.68. So if you don't know how to do that, we'll have the calculator do it for us. 82.95 minus 87.68. What are we left with? Negative 4.3. So we already have the first part. That's a negative 4.3. Now, this t statistic we've already found out was negative 1.03. But this is the t with the different alpha level. I think that's one mistake I'm making. I was just doing a regular t, but we want a t with the alpha levels divided by 2. So we're changing that. So we're changing the t value. I think that's the one mistake I was making. So we have to change the t value. We'll do that last. Okay. So let's first get everything else. So it's the square root. So it's going to be the square root of the variance 134.8027 divided by its n plus the variance, which is 144.96029 divided by its n, which is 15. All right. So now we have the square root of both the variances. This is called the, I believe it's called the pooled variance, or the the pooled variance. So it's 4.571. 4.571. So this whole thing is equal to 4.571. All I need is the t value, right? All I need is the t value. Now, when we did this before, there was the 2012, there was the 1988, there was the 2012. We want to make this less than 0. Now, before we were showing the critical value at 0.5. Now we're going to show the value at 0.025. Critical value previously was this negative 1.03, which is what we had before. Now this was not giving us the right answer. You can see why. So it's negative 4.3 minus this value, the t value, negative 1.03 times 4.571. And I get 0.408. That's not the answer, right? Because the answer should be negative 16. Should be a negative 16. That's not what we have. We have 0.04, which is not the right answer. So what I'm going to do, try to make this clear. Try my best to make this clear. is that I have to do the options on this, and I have to change this. I need a different T-stat. I want to make this a oh, 0.025. It doesn't change the T statistic though, it just changes their critical value. All right, so let's read exactly what they're telling us to do here. While either technology or the formula below can be used to find the confidence interval, this problem use technology. Okay. For the inequality, that's the sample mean, the size of the sample. Okay, and S1 is that sample standard deviation. The critical value is the value separating this on both sides. Okay, so that's what we got. Note that this confidence interval is being constructed to test a one-tailed plane, so the interval should be constructed with confidence 1 minus 2 times A. This means that alpha is effectively doubled for the construction of the interval. So our alpha was 0.05, and now it's 0.025. For this problem, use technology to construct the confidence interval. First, identify the appropriate confidence interval for a one-tailed test with alpha is 0.01. This confidence level is 98%. We enter it into technology and it's about the answer. So I still am not quite sure how they're getting this 98%. I know we could just basically type this in and get the 98%. That's not the way I want to do it. I want to at least see it work out. So let's do a similar problem to this. Fail to reject the null. There is not significant blah blah. Fantastic. Construct the confidence interval for this. And we're talking a T statistic here. We have a degrees of freedom of what? 10, 15, and 12. So that's 27 minus 2, that's 25. Okay. And we have a and we have a p-value of, oh, sorry, test statistic of -1. Degrees of freedom, p-value of -0.92 gives us this probability of 0.0331, which is what we got here. I'm trying to get that confidence interval. So, should be another way to walk us through that. Now it's a one-tailed test. So we have to double the alpha value. So 0.05 becomes 0.025, but I don't think that's going to help us. So let's see it with 0.975. Let's just double this and see what happens. I like seeing the critical value. All right, so our degrees of freedom is still about 25. I always want to pull the variance. Degrees of freedom is 25. Our lower limit, negative 21.00. Sorry, 0.01. And this is 2.62. Keeps giving me this formula. I did it with 0.975 as the value. The last one had 0.98, 0.2151, and 3.12. But I still don't understand how they're getting that confidence interval. So let's final check this. 21.51 and 21.01, and no, this isn't right. So let's look at a similar question. I'm going to go to the book. I'm going to see how they're actually getting these confidence intervals in the book. They're saying they're using some sort of technology, but for some reason, I'm not able to figure it out. All right, let's see how they say to do this with technology. We're in chapter 9. We're here with independent samples. Two samples are independent if the sample variables are not related to the other one. Okay, that's cool. Independent samples, heights of men and women, dependent heights of husband and wife. Okay. So we need standard deviations are known, and for a simple random sample, more than 30 of each. There's our T statistic. Degrees of freedom is smaller, n minus 1. And then n of t minus 2. That's how you get the degrees of freedom. P values, the critical values. All right, here we go. The confidence interval. Confidence interval estimates the differences between the population mean of 1 and the population mean of 2. And the number of degrees of freedom. Okay. Using technology. That's what I've been doing to get the T statistic, which is fine. Got to pull outside the critical value method. All right, here we go. But how do we know it's 90%? Repeat example 1 by constructing a confidence interval to estimate the difference between mean height in 1988 and mean height in 2012. Just had it. Okay, first we must be careful to use the appropriate confidence interval. The test in example 1 is a left tail test with a 0.05 significant level. We should construct the confidence interval using a 90%. See table 8-1, what shows the significant level for 0.05 should use a 90%. All right, so where is this 8-1 table? Table A-1. No, it's 8-1, not A-1. Here it is. This was the one that I couldn't find. Oh man, sorry that took me so long. I'll do it by hand too, but so a two-tailed test at 0.01 is 99%. A one-tailed test at 0.01 is a 98%. A 0.05 is a 95%. One-tailed test is 90%. A hypothesis test for 0.10 is 90% and one-tailed is 80%. So let's do it. That was annoying, but I have this. And I'm not even gonna look at the exact steps to get that 80% because I saw the table. Here it is. The table in all of its glory. All right. So let's go back to those problems. All right, we're doing a new one from the beginning. And now nothing's gonna stand in our way. Here's our data. We're using a 0.01 significance and it's one-tailed. So what does that mean? 0.01 significance and it's one-tailed. It's a 98% confidence interval right there. I knew that there had to be a table somewhere. Sorry that took me so long to solve. All right, so the null, they're always going to be equal. And we're saying that this, okay. Is less than. So here it is, less than. Boom, check answer, good job. The test statistic is what? So edit, statistic, t-statistic, to sample with data. There's the first one. There's the second one. And we're going to pull the variances. We're going to say that the first one is equal. The second one's going to be less than 0. And our critical value is going to be what? 0.01 significance level. Cool. Compute. Beautiful. So our test statistic is what? Two decimal points, negative 1.63. Our test statistic. Do I unpull the variances? Negative 1.67. Okay, not pulled variances. I'll survive. The p-value is 0.23 decimal places, 0.054. Perfect. All right, now this last piece, we are going to reject Fail to reject the null. There is not significant evidence. Perfect. And finally, construct a confidence interval. So we have one-tailed at the 0.01 level, it should be 98%. Which means we are from what? Negative 20 point, how many decimals? Round to 1 decimal place, negative 20.6. And the big one is going to be 4.0. Ta-da! Okay, so I know how to do it. I might as well be able to see this by hand anyway. So we have it. So this chart is what we need to remember. I'm going to snip it. New. I'm going to save this guy. Confidence interval, find percents. Cool. All right, so I got this guy. So let's see this thing done by hand and see where they get the weird t value. Obviously, I finally got it, so that makes me happy. Here is 9.2. And let's see them do this by hand, because we should be able to see it done by hand. The one thing is, how are they getting this t value of alpha over 2? That's regular t. So for manual calculations, we first find the value error in table A-3 with degrees of freedom 11 and 0.05 in one tail, we get this critical value. Okay, so we should be able to get a different t statistic. So here we go. Calculator, t statistic. We're talking degrees of freedom is 11. Okay. We want a 0.05 with one tail, but we want this in the other direction. Here it is, degrees of freedom, one tail, other direction. That's how you get that 1.796. So it is the critical value of the t. You can't just use the t statistic. This t of alpha over 2 is your critical value of your t. So let's go right back to that problem we did. All right. Now we got this t statistic, right? Now our degrees of freedom is different for this. So let's look at it. So now we have degrees of freedom, right? Our degrees of freedom is 25. And we're talking it's one tail. It's one tail. And we're gonna be at the 0.01 level. But even though we're at the 0.01 level, we have to be on one tail. One tail, 0.01 level. What is my critical T? 2.485. What do we get? 2.485. Beautiful. So we get the exact thing we need. Now, if we were to do the rest of this by hand with the means, we would get the same exact answer, which is really, really nice. Sorry it took me so long to do this and figure it out, but guess what? I'm gonna see it by hand too, considering we did everything. So to get this, we need this T statistic, which we just got, which is 2.485. Just so we can get the error. So we gotta multiply this to the square root of what? We're multiplying this to the square root of the variance of the first one. So I just need stats, calculator, summary stats and columns. Cool, compute. So the variance of the first one is 130.2372 divided by 12. And all I have to do is multiply this. I believe it's multiply and not add, but we're going to find that out in a second. It is add for the error. It is add. Sweet. Because I was using the T statistic and not the critical value. That's why I kept messing it up. But that's okay. So we're adding this together. So the value on top is 204.76267, and we're dividing it by what? 15. This has got to be our error. We've got this error of what? 12.30. So to do this, all we have to do is subtract the means and basically add this, and we should get the lower level. So here we go. The first mean is 86. Do we subtract these, and then we subtract the other one? So it's 86.28.29. 86.29 minus 78.00. We subtract the 12.30. And look what we got. We got this 4.01. I got 4.02, but that's the wrong limit. Let's add that. And there's the 20. Sweet. So there's how you get the 20.59 and the 4.02. We got the two values. I think I just mixed up the order of these. Yeah. So it should have been the other one first. That's okay. Minus 86.29. Here we go. And we got the whole answer. Negative 20 to 4.01. Sweet. So I know that was really long. Glad I figured it out at the end. So how do we get the confidence interval? Well, you have a choice, right? What's the choice? You can use the this table, right? You can use this table. This table will tell you exactly how significant it is. Your other choice, if you don't like this table, I would use this table. If you don't like this table, what could you do? You can go into StatCrunch. You can go into StatCrunch, right? And to get that T value first for the percentages, all you have to do is go to statistic, calculator, T, and you put in your degrees of freedom. So in our case, our degrees of freedom was 20, was it 27, 25? Yeah, it's 25 because it's 27 minus 1 for each group. So that's the 25. And all we have to do is put in the value we're looking for. But we have to change it to be this side. And we get the T statistic we need to solve the problem. Oh, sorry, it was 0.0 for this one. And we get the 2.485 that we needed. Once you have that this is 1%, or once you look over here at the piece, and you see it's 1%, right? Um, as soon as you have this value, like the one that we're gonna use, you're gonna be fine. You're gonna know exactly. I would just be like, okay, I know exactly what my confidence interval needs to be, and that's how I can get it. And I would just type it in, or you could, you know, work your way into using the other one. So we know that this is 0.01, and that's why when we do this, we get the right pieces. We go to options, edit, you could see that it's at the 0.98. It's a one-tailed test at 0.01. Beautiful. Compute, we got the right answer. The other way to solve it is, the other way to solve it, you basically have to do what? You have to take the values and you have to put the right t value here using this formula to get it. So use this one and Desmos to get it, or you don't want to think, just use the chart. Okay. No, that was super long, but I couldn't figure it out too for a while, which makes this hard. Good luck with them. Hopefully that was really useful. I try to show it as many ways as I could. And let me know if you have questions.